It is started.
So this is a 4-bar linkage with the triangular link 3. We want to find velocity and acceleration of all elements, omega 3, omega 4, alpha 3, alpha 4, velocity acceleration of E. And the dimensions are kind of a scale. The lengths are given here. And omega 2, link 2 has omega and alpha of 2.5 and 1.5. So we're going to start with velocity, right? So when we do the velocity, the first step is to write the equation. I mentioned always that when you want to do this, you have a couple of links with a certain type of motion, either circular or translation. If you have slider, you pick the link with general motion. Usually link 3, and you can distinguish whichever the numbers may change. You pick the link with general motion. You have information about one end of the link, which is B. You have velocity acceleration from link 2, and then you relate it to 3. So what I'm going to do is this, to write VC, I'm going to relate C to B. So VC is VB plus omega BC cross R C respect to B. So I need to find VB because omega 2 is given. We can calculate that. So I'm going to write it here. VB will be RAB omega 2.
Yep.
You calculate the numbers for me. And we know that VB is also perpendicular to RAB.
Is RAB 4?
4, yes.
Okay, so that makes 10.
Is it going to be 10 centimeter per second. And VB is perpendicular to RAB. So I put my reference point here as O prime. Then I will draw a line perpendicular to this from O prime. So one way to do it is to make this kind of like a slider, come here and draw a line. Because omega is this way, velocity of B has to be this way.
Yep.
And I'm going to use the scale of 1 centimeter for 2 centimeter per second. Which means 10 centimeter per second will give me 5 centimeter of the vector VB. So it's going to be here, and I will erase the rest.
Okay.
Now, I have got this velocity term. About this term, I know omega BC cross RC respect to B is perpendicular to BC or RBC, right?
You know that the movement of...
This term, because
Yes.
it's a cross product, is perpendicular to this link.
Yep.
And it has to be added to VB. So I will draw a line from end of this perpendicular to this term. And that's how we can do it. If we get this, and if we get this, then we draw a line from end of VB.
And you do it from the end because you're constructing it. You're
Yes,
constructing
because
BC
we
from-
add
yep,
these two
yep.
vectors together, so you have to do it from end of that one. So, and you're gonna have a line like this, which could be either way. Now, from the, so I drew this, of course not the magnitude, but
Yeah.
the direction. From VC, I do not know the magnitude, but
you know the
C
direction.
rotates about a fixed
D.
point D, which is circular motion. So VC is perpendicular to RCD, right?
So you will draw a perpendicular line from the origin.
From the origin, because it's the other side of equal sign. So I will draw a line perpendicular to this from this base. And to do that, I use this as a guide so I can slide this back and forth, right? So when I do this, I draw my line like this. And this triangle is constructed here. This is going to be my VC. This was already my VB. And this term will be
omega BC.
omega BC RBC. I can call this point as B prime, this point as C prime. If I want to find omega 4, because VC is equal to RCD omega 4, then omega 4 will be VC over RCD, right?
Yeah.
So I have VC, I can measure it and scale it back to the number. So this looks like 4.4 centimeter. So my VC is 4.4 times 2, which is my scale. It's going to be 8.8 centimeter per second. Therefore, my omega 4 will be 8.8 divided by 6.
You want a fraction?
No, it's okay. Which is going to be 1.47 radian per second. If I want to find omega BC, I'm going to have to measure this length and then divide it by RBC. So this length is going to be fairly 3.5. So omega BC RBC is 3.5 times my scale, which is 2, and it's going to be 7. So my omega BC is 7 divided by RBC, which is 7,
Oh, okay.
and it's in the
Yeah.
1 radian per second. Now, if I want to find velocity of B, I have to reconstruct this triangle on this line. B goes to B prime, C goes to C prime. So technically this line, which I make a little thicker, represents this line. I need to measure this angle. And the angle seems to be 49 degree. So when I want to see, because you can look from this way or you can use this way, it's important to know when I look at B and measure this, C is to my right hand side. So I look at B, put C to my right hand side, and get that 49 degree angle.
Do you have to do it by angles, or could you also use parallel lines and perpendicular lines?
For velocity, you can do perpendicular because each of them is perpendicular to one. But for acceleration, that's not the rule. So it's easier just to use with angles, right? Because you have to construct a similar triangle here. And again, I measure this angle. It's 34. And when I measure C, B is to my left side. So I turn this, put this on C, B to my left side, and measure 34. And draw this line. And this is my triangle. I'm going to use a pencil to highlight this a little darker so you can see. So this triangle with the black pen, this is the velocity image of this triangle. Therefore, this point is going to be E prime. Now, if I want to find velocity of E, I have to connect it to my origin and measure that length. So if I do that, this is technically, this is VE. And if you want to measure how much it is, it goes almost 5.95. So VE is going to be 5.95 times 2.
And then divided by the...
No, divide, no, just the
two is the
velocity. Just 2 is the scale. So it's going to be 11.9 centimeter per second. So I've found every velocity term and omega term here. If this thing was attached to something else to continue, you could use this velocity and write relative motions again and move forward. So this is the velocity part. For acceleration part,
there would be some omega if it was connected.
It could be. It might be a link and a slide on something, and that link has omega. You write this equation one more time.
Okay.
I'm just gonna explain, like, I don't do it, but suppose that this link is attached to something here, and this is gonna slide on a vertical line, right?
Mm-hmm.
And this is point F. Now that you have velocity of E, you can write the same equation between E and F
Mm-hmm.
and make another relative velocity vectors and continue from there.
So VE here, VF here, and then
Yes.
omega FE.
FE, and this
Start
is going to be
cross.
RFE,
Yes.
and then the velocity of F is going to be in this direction. It could be
Mhm.
even 4-bar linkage or whatever, but we're not going to continue that part
Okay.
because it's just same thing. You can continue.
Thank you.
To do the
Acceleration.
acceleration, I'm going to stick these two together so I can use it easier to draw the lines perpendicular and parallel. For acceleration, again, I'm going to start between B and C. AC is equal to AB plus alpha BC cross RC respect to B minus omega BC square RC respect to B. And you notice that omega square is not a vector, it's just a number.
Mm-hmm.
AB
The units don't work, right?
has two components as a vector,
Mm-hmm.
right? Is AB normal plus AB
Tangential.
tangential. Can you check if it's visible here?
It has become unfocused. I don't know how to. Okay, it's focused again.
Okay. So AB normal is going to be RAB omega AB, which is omega 2 square, and we have the number.
Mm-hmm.
AB tangential is going to be RAB alpha 2, which we have it as a number. Alpha 2 was 1.5, omega 2 2.5. So I know everything about this point. Alpha BC, we don't know it, so you cannot draw it. But this term, we calculated in velocity part already, right? So omega BC square RBC or RC respect to B as a vector, we can also write it as omega BC square RBC. This is going to be how much? Omega BC was 1 and RBC is 7, so it's technically 7
Okay. Yeah.
centimeter square per second square.
Alpha was
1.5.
1.5 times 7. Well, that's just.
No,
10.
it's not fine. This is for this. Alpha. This is RAB. So alpha times RAB. RAB is 4.
Oh, okay. 1.5 times 4.
Is 6.
Yeah.
And omega 2 is 2.5 square times 4. Can you do that?
What was the first one?
2.5
Squared
Squared.
times 4.
Yes.
Yeah.
It's going to be 25.
Yep.
Okay. 25 centimeter per second square. So I find these terms. I found these terms. I can also find one element for AC, because AC also has a circular motion. Therefore, it has normal and tangential axis. C and B don't matter. They're similar. It's just this is input, this is output, right?
Yeah.
So AC as a vector is going to be AC normal plus AC tangential. AC normal is going to be its own omega, so RCD omega 4 square. And we have found omega 4 to be 1.47 square times 6.
12.96.
Almost, okay. 12.97
9.97.
centimeters second square. So now my numbers are in order of 10, 20, 25. So I make the same scale of 1 to 2.
Mm-hmm.
So 1 centimeter here is 2 centimeter per second square. So we don't get it too big, right? I put my O double prime here, and I'm going to start from this vector. AB has two components. Normal, which goes from A to B,
Mm-hmm.
and tangential, which is perpendicular to
Mhm.
this. So I'm going to draw a line parallel to AB from O prime, and it's going to go from A to B, so it has to go kind of down here.
Check again while you're drawing that. It looks good.
So the normal is 25 centimeter per second square, so with the scale it's going to be 12.5. So I will make a line 12.5
In the direction of the fixed position, because that's how.
it goes toward
Normal
the
works.
center. It's always toward the center.
Yep.
And this will be your
No.
AB normal.
Mm-hmm.
The tangential will be perpendicular to
Mhm.
this, which means perpendicular to this. The length is 6, so with my scale it's going to be 3. So I need to draw a line perpendicular to this. And because alpha is also this direction, it's going to be this direction.
Mm-hmm. Yep.
So this has to
Following omega.
follow. Yeah. So I'm going to draw a line here, right?
Yeah.
And the length is going to be 6 divided by 2, 3 centimeter. So this is my tangential axis. Oops. This will be my tangential acceleration from here.
And you chose AB because you had a component of its acceleration, or two components in this case.
Yeah, that's your input. You know everything about it, right?
Mhm.
And technically, this is AB tangential, and this is your B double prime. So your acceleration of B goes from here to here, the
Mhm.
overall number. I have done this. I do not know this because I do not know alpha. So I'm not going to draw this first. I'm going to draw this first because I
Mhm.
know it. Again, omega BC RBC is going to be parallel to this going from B to C,
Yeah.
and we got the number 7.
Mm-hmm.
So I will draw a line from here parallel to this line. To do so, and because this is added to this, I have to draw from end of this.
I'm sorry. Why was it parallel again? Is
Because you see, this is
dot,
a number.
Dot product.
No.
Oh.
This is a number. So only R is a vector. So
Mhm.
it's in this direction. From RCB is from B to C. With a negative, it goes from C to B.
Yes.
Because it's like a normal acceleration, so it goes to the center. So I will draw a line from here in that direction. The number is 7, so we have to go 3.5. So I will draw the line first. And then make a sign of 3.5. They are very close to one another. That's just accidental, right? So this is your omega BC square RBC. The last term to draw here is this vector,
Mm-hmm.
which is perpendicular to RBC. I can write here
Perpendicular to R.
alpha
Okay.
BC cross RC respect to B is perpendicular to RC respect to B. So I need to draw a line perpendicular to this from
the
end of this vector,
yeah.
which is technically we can just do perpendicular here, right?
Mm-hmm. Because the tangential and normal are perpendicular.
Perpendicular, yes.
And you didn't draw to the line. You knew the number, so it's just
Because I don't know
yes.
the number, I draw this.
No. I mean this one. It was not crossing. It was you knew the number.
Yeah.
You knew the magnitude.
Yeah, it has nothing to do with this
Yes.
line. It was accidentally close.
Mm-hmm. Yep.
Now, I completed the right-hand side of equation, normal, tangential, this term, and this term. Now I'm going to go back to the left-hand side and start from here, from my origin.
Yes.
I need to find normal acceleration of AC, which I already have it. So AC, normal, can you calculate this? Omega 4, which was 1.47 square
Yep.
times 6.
96.
Okay, we have it here. Sorry, we have it already here. 12,987. So you divide it by 2.
Why
No, we had it this already.
was it not 4? Is it not 4 squared times 6?
It's not 4. Is
Where did?
omega 4 is 1.47.
Okay.
So
Oh, okay.
yeah, this is the number.
Mhm.
Now divided by 2 is going to give us 12.48 something. Sorry, 6.48. I'm going to draw a line. Now, this is again normal acceleration. Normal acceleration goes from C to D.
Mhm.
I have to draw a line perpendicular to this
Mhm.
from this point and going this way. So to do that, I use this 2 again. And the length should be 6.5 almost, 6.48, 6.9. We're gonna go 6.9 because it's hard to go.
Were we dividing it by the scale? Oh wait, you already did. Never
Yeah,
mind. You're
yeah.
good.
6.49, almost 6.5. So this is AC normal. The last term here that we don't know is AC tangential
Yeah.
here. And I know it's perpendicular to this. I do not know where it goes, so I'm just going to draw a line perpendicular to this from end of that, because these two should be added together to make AC. So when you do this, this is the extension, and this is the extension of the other line I drew. So I continue this.
Alpha B.
Yes, this guy. No, no.
Oh,
this is the
okay.
now this is my point. Technically, this is my C double prime.
Mhm.
This will be AC tangential, and this vector here, this is going to be this vector.
Yeah.
Alpha BC, RBC, right?
Mhm.
And we can make it a little darker, so and same here. So if you want to find, for example, alpha BC, you measure this,
Mhm.
you scale it back, divided by RBC. If you want to find alpha of link 4, you measure this, scale it back, divided by R,
Yes.
because we actually use this equation,
Mhm.
right? We didn't write it, but for the tangential. And one more thing, C double prime, D double. If I want to find acceleration of E, I have to reconstruct this triangle again here.
Mhm.
So to do that, I will draw a line between C double prime and B double prime. And-
Should we at least say acceleration C while we have it?
Yes, this is acceleration C,
Mhm.
we calculated, right? Or we determined that calculate, we draw it, so it's end of that. So this line represents this line, right?
Yes.
So you see, if you go here, BC, you have to construct it this side. Again, the angles, I think this was 34, am I right?
I don't remember the angles.
Oh, we can do it again. Yeah, this was 34, and this was like 49-ish.
Mhm.
So I'm gonna make an angle 49 from this end. And draw the line. And I'm going to draw a line from this end as 34.
You're placing parallel to B, finding angle to
Yeah.
or to C, and then doing okay.
And this intersection, this is technically your E double prime. I will highlight these lines with this purple color so it shows which triangle is this. So this triangle represents this triangle. Therefore, if I want to find acceleration of E, I will connect it to my base.
Mhm.
and measure that vector. So technically, this will be your acceleration of E. Right?
Yes. Acceleration.
And you can measure, scale it back to whatever we had. So this is like 5.65. So I'm gonna write here AE is 5.65 times 2,
11.3.
which is 11.3 centimeter per second square.
Square.
If I want to find, for example, alpha of 4, I have to measure this length. So technically, AC tangential is RCD
Times
alpha 4. Therefore, your alpha 4 is going to be AC tangential divided by RCD. This is my AC tangential. I will measure this. 4.4 times 2 divided by RCD, which is 6.
6.
No, divided.
Oh, sorry.
8.8 divided by 6.
I did not. Okay. 1.47.
47 radian per square second.
Mm-hmm.
And if you want to find alpha 3, you have to use this length because this is alpha BC times RBC, right? If look at this is my alpha BC from the end of this.
Yes. Yeah. That makes sense. Yeah.
This length, so, and I'm gonna write it here. So alpha BC RBC is equal to 14.7 times 2.
It's just 29.4.
29.4 centimeter per second square, and your alpha BC will be 29.4 divided by RBC, which is 7.
4.2 centimeter.
4.2 radian
Oh.
per square second. So if you look, this is alpha BC, this is alpha 4, this is AE, and the rest we calculated. So now, suppose that you want to go find acceleration of F.
Mm-hmm.
You're going to construct this again between F and E and go from this edge.
Where this is E and this is F.
Yeah, this is, for example, if you want to do that, you may write, for example, I'm going to write it here, AF is equal to AE plus alpha FE or EF cross our F respect to E minus omega EF square our F respect to E. And this term, if you solve the velocity, you can find it exact same procedure.
And because it's negative, it would be the other way.
Yeah.
Yep.
So that's how you do these problems.
Okay.